What's going on? Today we're going to be doing a couple of experiments with my pendulum. I've got a speaker magnet here, just plain ferrite speaker magnet. Have the same exact one from the same speaker set, but this one is covered in alternating north-south, north-south N52 magnets. And this is regular. We're going to see what the differences are. Now, so you see what the setup is. Just fishing string with a double-sided, I have a M52 washer shaped magnet on each side of this ferrite magnet. So one side's north, one side's south. Very strong. And we're going to watch and see what happens with just a plain magnet placed here. This is where the pendulum would hang should we not have a magnet swinging. I don't know if you can see this. I'm just going to swing it straight past it and see what happens with a straight swing versus going in a circle, because it will go in a circle and do what I call magnetic tidal lock. Same sides facing the center, and it will continue to do that until it winds the fishing string up some, and then it'll start going in reverse, and it'll do that back and forth for quite a while actually, and then it will, finally eventually completely stop. Alright, now it's not going to change much from that except slowing down and then going the opposite direction. So let's change this up and see what happens. See if we get a different effect off the alternating M52 magnets. The other one will just keep spinning smoothly without any hesitation. And I'm going to do the same thing. I'm going to just drop it straight across it. As you see, we got a lot of jerking around. It's not wanting to go in a circle. Alright, now let's try it with a circular swing. See if it messes that up or if it continues to go in a circle. It's hard to see on the camera, but it is making jerk style movements, twitches. When it's just a plain magnet, it is a very smooth orbit around the center magnet, but I am seeing like slowing down and speeding up and wobbling. You can see the stick in person getting a little tug on it here and there from where it's not spinning as smooth. But as it's progressed, it does seem to have taken a smoother course. It's not as jumpy as I was seeing a minute ago. And honestly, it's staying further away from the magnets and spinning in a larger circle than the other one was. But I did, spin it in a circular motion this time. So let's see what happens. It's doing the part where the string is wound up and it's going to start going backwards to unwind the string. Now I'm going to get a swivel on this to get rid of that part of it. I've had some configurations that seemed like they were going to continue on perpetual motion and all, and then the pendulum could be replaced with an arm to make the arm spin around in a circle and turn possibly gears or pulleys to actually generate power if we get a configuration that continues to move regardless. And this does seem to, hold a lot of its momentum, because even when it slows down from the string winding, and goes back the other way, it picks its speed right back up. Alright, this is going to do the same thing. It's going to slow down, it's going to reverse itself, and eventually it should come to a complete stop. You know, well, it will come to a complete stop. Let's try something a little different. Okay, here I'm going to place, as you see, this is the side that is pushing against the magnets and won't let it go over top of the center magnet. Well, on that side, I'm going to place this stack that attracts the magnet. So this is going to be pulling the magnet towards the center. It's not wanting to stay centered up, so that's going to be off centered a little bit. Do a straight path and see what happens. Well, that was short and sweet. Alright, what I have to do on this is I'm going to adjust the height of the pendulum because it's a little bit too close and it's running into the magnet I put. Now, let's do the drop. See if we get any different effect or if it's still the same tidal lock motion. Definitely stopping the tidal lock effect. As you notice, take it away, give it the slightest little nudge, and you're back to spinning in a circle again. Now, another thing to point out is I do not have the magnet on top that we were using before. Trying to find it here. Wait, yeah, I do. It's on there. Need to drop it back down some to get the best tidal lock effect. I'm going to try to see what these magnets here. I've got these space pulling in the same as I did before, pulling it towards it while the round larger speaker magnets are going to be pushing away. So I'm going to see what happens with this configuration. It's going to want to go to the middle, but the speaker magnets won't let it. I don't know if you can see that, but it's jerking the pendulum arm is being yanked on, and if you can hear it, the magnets are getting tossed around. It seems to be doing slightly elliptical orbit. It's going farther away from it to the left side of the screen than when it's on the right side, like a planet getting slingshotted through space in a different direction by a planet's gravity. It seems to have been doing a little bit of that, going farther left than just a perfect circle, more like an elliptical egg-shaped orbit. Now it's, you know, in person I can see it's centered up and it's found, you know, it's equilibrium, so to speak. You know, it's staying right in the center where it wants to be. I'm going to try that one more time because I haven't seen one do an elliptical orbit before where it goes farther out on one side. And it actually seems to be doing that again. It quit pretty quick, but I seen it slingshot it, you know, a couple of times when I first started out. It does seem to grab it and throw it in one direction, but that straightens back out. So these little round magnets are having a big effect on it. Just to finish it off, I'm gonna do one more just straight drop instead of pushing at an angle, and see if it doesn't just go back into a circular orbit type pattern. And there we have it, it does. Put that in there, see what happens. Very little effect on that. Now, I'm going to try a couple other things. Okay, now you see here I got some M52s stacked up, about 6 of them or so. See if it has an effect on it. And it is stopping it, and it's holding it in place. It's not wanting to let it do its orbit. So it's most definitely affecting it. Let's try something a little different. Find out which side is pulling towards it. That would be this side. I'm gonna face it up. Make it be pulling towards the middle. It's wanting to stick to that, but it also can't go past the magnetic field on the center. So these other magnets out of the way. These magnets have a large range of magnetism. And there we go, it had a big effect. It had a much smaller circle, and it sucked it towards the middle pretty quick. We're gonna try spinning it in a circle and see what happens, because it's pulling right now. Them center magnets are pulling that pendulum towards the middle, but the speaker magnets are the opposite polarity and are pushing them away. So it is being pulled and pushed, and it has a very different effect when it started off in a circle. Now it's gonna wind down and get closer and closer to the center. It's going to stretch that fishing string once it gets pulling on it real hard, and then it's going to touch. I'm thinking about 3, 2, 1. You know, next couple seconds, stuck. Bam. Stretch the fishing string and stuck. Now, we didn't figure out perpetual motion, but this is how you perform science. You do ridiculous little experiment after experiment until you prove something right, you know. And this is just a few little quick, you know, experimental tests to see if we can get that pendulum to keep moving. And if we ever do, then we will have a machine that keeps moving with a few modifications. So I hope y'all found this interesting, and y'all have a great day.